Hi guys. So I was. This is the second attempt, actually third attempt. First time was a test one, and this is a third time. Second one, I did some introduction to this video, but I unfortunately I have forgot to start the recording. So here we go again. So before I start, I want to give you full disclosure. This is not a tutorial or something like that. I'm just doing this to teach myself to use a called Feynman technique. But I find it very, I find that I find it out that I can. And second thing is, I need to improve my English. So I can quite I can understand English and uh, speak English quite well, but unfortunately, due to lack of uh, speaking, uh, I can't speak fluently. So this is my attempt to try learn English and also study my module. And I'm recording this, so I have a what do you call uh, give this a meaning, okay, right? So if I record the when I record this, I can upload to this YouTube or something. So if someone find this useful, they can watch it to understand a little better about some subject. uh, that's the main gist of it. uh, so full I'm going to do the full disclosure again. This is not a tutorial. This is uh, intended to me to understand the subject material better. But this may be useful for some of you if you don't fully grasp the subject as I did it, as I did it. Don't know is the right word. So I know you got. I think you got the point. So I hope my English will get better doing this for some time. So let's get into it. So going to talk about linear algebra, which is as I heard and I watched some non-tutorial like intuition or maybe informative videos about linear algebra, and got to know about what is basically linear algebra and what is are the uses of linear algebra and applications like that. So it came to my understanding that linear algebra is used widely used in very wide applications such as computer graphics, computer graphics, and number manipulations and basically computer based calculations to them do more effectively rather than uh, coding everything. So for example, uh, I think you are watching this on a, and I am recording this on a screen. So screen is let's say my screen is made out of uh, 920 pixel on width and height on or 1080 pixels. So it is there is a so there if we when we go talk about the display, how is displaying information is there is a uh, each pixel has three colors are GB, as you know, red, blue, and green. So the specific combinations of these values produces different color. For example, if I the maximum for a 8-bit panel, maximum the value can be is 225. I don't think you need to know the specific of this. I'm just giving you example. That's it. So the radius, sorry, radius, not radius, man, red. Let be red is 225, blue is 0, and green is 0. This will produce a red pixel. Similarly, if we get 255 on blue, other 0, we get a blue pixel. Any other combination, if you want to produce, let's say, magenta, that would be 220, 255, 255, and 0. That will produce magenta. So, this is, I don't know, this is the exact way the comparison works, but I am giving an example what we can use linear algebra. The linear algebra first made from started on using matrices and vectors. These are very useful in especially in uh, number manipulations and things like and computer graphics such that. So when as I heard, first these subjects were developed, then mathematicians came to understanding that these are very special cases of a broader mathematical field which encloses the same kind of techniques or laws or axioms or definitions, something like that. So, for example, vectors and matrices can be generalized to one particular field of field in not in sense of mathematical definition of field, just the language literal meaning a field or group of that's a very group of same group of some objects which has same properties. So mathematician did was what mathematician did was they try to generalize to a greater extent that which this objects, so that we can use widely a very wide range of applications and have a solid called what do you call foundation to this mathematical objects and the operation regarding those. So so they what did they did was is they abstracted this idea abstract and called it abstract algebra, yes, abstract algebra, also called as known as linear algebra. I will get back to why maybe it's called linear algebra uh, to my understanding a little bit later on this series. So that's the thing. So uh, we got on a tangent. So what was I talking about is the red, green, blue pixels, right? So if you want to what do you call display a picture on the screen, we can use a matrix, actually three matrix which has, let's say this is R matrix, which is red matrix, which has one 1920 rows, sorry, columns, and 1080 rows, which has the value for each pixel for each red value for each pixel. Let's say 245, 0, 128, 231, etc., etc. Similarly, they can have uh, similarly blue matrix, and uh, other one is green matrix. So so finally computer just have to do is just have to display green plus red plus blue plus green to produce a picture. So what you're looking at your screen is might be very complex and very intricate graphics and very colorful, but ultimately you can transmit that information from your computer to the monitor using a HDMI or some kind of interface, uh, just using numbers, right? So I don't know. This is the exact way the computers work. But this could be used as. And I think similar the workings of the computer communication between computer what do you call it? Graphic information between monitor and computer is based on something like that also. But if I'm wrong, you can correct me on in your comments. I would try to uh, read the comments. Yeah, that's about it. So this is very wide use of applications. uh, so people try to generalize it, as I said, came up with a very new field called abstract algebra, right? Might For some of you, like myself, uh, this subject might not be intuitive as other like other mathematical uh, topics, right? Like calculus, derivatives, differential equations, like that. There are direct world applications from those things, and we can use them intuitively to get some useful results and useful calculations, do useful calculations. But this might not, this subject, the linear algebra or abstract algebra, might not be for the sorry for linear algebra or abstract algebra. That might not be the case. So I'm trying to as a student, I try to understand this using vectors and matrices. uh, Vectors and matrices, I think that's the way mathematicians have developed this idea. So they had vectors and matrices, they try to abstract those objects. So I think they took very good inspiration from those objects to came up with the solution. So I'm going to do the same thing. I don't know whether it's the way it was done, but that's the way I'm going to do. So I think this is for the introduction. That would be enough for us. This might not be very clear for everyone, but I try to uh, explain. Actually, what I'm doing, I'm trying to explain to myself so I can understand it. So maybe you guys find this useful. Uh, I'm going to cut this video from here. We can join. You can join me in the next chapter or the section. So see you there.